Okay, let's see one that we work in the entirety together. So first of all, we're given our function y equals. Um, we're going to do this in terms of the x. Now, if it doesn't tell you specifically to use the integrate with respect to x or with respect to y, usually you can, and you have the option, it's usually easiest if it's given to you as a y equals, just to go ahead and work with a dx. If the equation was an x equals equation, you may want to use respect to y. You should get the same answer either way, but one's going to be a lot less painful than the other. So in this one, we're going to go ahead and do with respect to x. So first thing I want you to do is take the derivative. Okay, good. So you have your derivative here. So it's 3/2 times this, which would give us 3/4 in front. And then minus 1 would just give us the 1/2. The derivative of 1 is just 0. So let's plug in what we have at this point. So that's going to be, what's our x values? 0 and 1. So 0, 1, we'll have 1 plus, let's plug in our derivative here, 3/4 x to the 1/2 power. That's going to be squared dx. Okay, let's see what we can algebraically simplify first. Go ahead and square this term. Okay, we multiply them out over here. 3 times 3 is 9. 4 times 4 is 16. When you multiply like bases, add the exponent. So it simplifies to this. Now, we're ready to go ahead and take the antiderivative of this, but we can see that this is a pretty ugly thing, so we're going to have to use U-substitution. So we're going to go off to the side and we're going to say U is equal to 1 plus 9 over 16x. So what would du be? Derivative of this is nothing but what's the derivative of this term? 9/16 dx. Okay, so if our u is going to be this term, our du is 9/16 dx, we can rewrite this as u to the 1/2 du, but the 9/16 is extra, so we account for that by pulling 16/9 out front. Go ahead and take the antiderivative of this. Okay, so we have our antiderivative and we have it set up. Now I have two options here. I can either leave it in terms of u, but then I would have to change my intervals here. These intervals are in terms of x, right? They were given. So I'm going to go ahead and replace this u and rewrite it so that everything's in terms of x, so I don't have to change it. So 2/3. What do I put in place of u? We go ahead and plug this back in. So we'll have 1 plus 9 over 16x to the 3/2 power, evaluate it from 1 to 0. Now, for those of you that want to evaluate it and stay in u, you got to change these with respect to u. Meaning when x is equal to 0, you're going to get different values for here. So you have two options there, but I'm just going to take it, rewrite it back in terms of x, and now I'm going to evaluate it because I have nice numbers over here. 1 and 0 are nice things to work with, so we're going to do that next. We'll calculate it on the next page. Okay, so you can see if you did the left it in terms of u, you would have to evaluate this, or if you're going to be with us, we're going to put it in terms of x and evaluate this. Okay, so we're going to evaluate this. I wrote it down. The first time I'm going to plug in a 1. The second time I'm going to plug in a 0. Be real careful with your parentheses. And then simplify everything in this parenthesis first, which is 25 over 16, and then raise it to the 3/2 power. Over here we want to simplify everything here and then raise it to the 3/2 power. Subtract and get your answer, and then multiply by 32 over 27, and we should come out with 61 over 54. Okay, so now we're going to find arc length of a graph given. This time we were given an x equals. So let's go ahead and integrate with respect to y since it's set up for that. So we want to make sure that we use y values for our intervals, our c and d, and we're going to plug it in here. Now the first thing we want to do is go ahead and be able to find, we got to find the derivative. So let's work on that. The first thing we're going to do is rewrite this. We're going to move this up to a negative exponent so that we have this. And now we're going to have to use our chain rule. So let's do that next. Okay, let me just show this first step. So we say 4 times 1/4 is just a 1. We have this term and then to the third power. Then don't forget we have to do the derivative of the inside. Okay, moving to the second term, we say negative 2 times 1/8 is negative 1/4. Y plus 2 to the negative third power, and then we take the derivative of the inside. Okay, y plus 2 to the third, the derivative of this is just 1. And we bring down minus 1/4, y plus 2 to the negative third, the derivative of this is just 1. Let's go ahead and use this now as our derivative to plug into our function, into our formula. Okay, so putting my x prom from the last page over here, substituting it in, remember we're using the y values, so 0 and 2, so be real careful with your intervals. 0 to 2, 1 plus, and then our x prom squared here. Okay, let's go ahead and simplify this portion right here algebraically. Alright, so we're going to have to come off to the side and FOIL this ugly term right here. So basically I brought it to a scratch page and you multiply the term times itself. When you have y plus 2 to the third times y plus 2 to the third, you get to the 6th power. Now this is the one I want you to pay attention to. So if I have this term times this second term, I have y plus 2 to the third, but I also have y plus 2 to the negative third. But so when I add 3 and negative 3, you're going to get y plus 2 to the 0 power, which anything raised to the 0 power is 1, times the negative 1/4. So we're just basically left with negative 1/4. Now, the same thing is going to happen whenever I do this term with this term. The negative 3 and the positive 3 zero out, so you would have y plus 2 to the 0 power, which is 1 times the negative 1/4, so that's negative 1/4. This last term times the last term, you're going to get a negative 1/4 times a negative 1/4 is a positive 1/16, and then negative 3 plus negative 3 is a negative 6. So let's take this and put it back into our previous page. Okay, this half is a negative 1/4 and a negative 1/4 simplifies to be a negative 1/2. So we have negative 1/2 there plus 1 over 16 times y plus 2 to the negative 6 power. Okay. Okay, good. So in the last one we saw highlighted, we like when we have this 1 and then the minus 1/2. So when we simplify that, it's just going to give us a positive 1 minus a half will be a positive 1/2 in the middle. So we rewrite that. Okay, good. Simplifying 1 minus a half, we have this positive 1/2 in the middle. And now this factors. And this factors for the same reason. Let me go back to this previous page where we did that work on factoring right here. So when we have this and we have a 1/2 in the middle, we can see that our terms factor into a perfect square. So you can go out to the side and try that on your own, or we can rewrite this next step in factored form. Okay, so we rewrite this. Now this square root undoes this square, and you're going to be left with just this term. And then you're going to take the, go ahead and evaluate that. Okay, so now a couple of things. You may be tempted to want to use a u right here. So if I say u is equal to y plus 2, then du would be the derivative of that, which would just be 1. Okay, in this case 1 dy, but this isn't going to change anything. So technically we could just still go ahead and do this because this is not necessary in this particular case. But that is the mindset that we use. And if it did have something other than 1 dy, we would have to use U-substitution. Okay, so to the fourth power divided by 4 gives us this term. Plus 1 is -2, so this divided by -2 is -1/8. Y plus 2 to the -2 power, evaluated from 0 to 2. Okay, and then substituting the values of 2 in the first time and substituting the values of 0 in on the right side, simplifying, you get a really big fraction, which is approximately 60.023.